Welcome back to College Algebra. Today we're going to be looking at section 4.1. Just a note before we start today, chapter 4 is different than all the other chapters. It is in itself its own chapter that you're going to be tested on, and so this week is a pretty unique week. We're only going to be looking at one section today, and this is the only video for chapter 4. So as we prepare for a test this week, I would encourage you to really study and learn this section. And really buckle down as we go through these topics about linear functions. The reason for this, linear functions are fundamental to all of mathematics. Linear functions are like the stepping stone or like the groundwork for everything that comes after it, which is why slope and the things that you get with linear functions that we're about to see in a second are fundamental to understand and deserve their own test. And along those lines, rather than a scripture for the day, I think that with just such a famous function, we could go to one of the most famous scientists in all the world who said that mathematics is the language with which God has written the universe. Galileo said that, and to me, though I can't talk to Galileo, that kind of means like there's a lot of things that humans wrote. Humans have written history books and English and stories and television and art and media and paintings, and all of these are human aspects of subcreation under a bigger creator God. And Galileo here is observing that mathematics is not something that we created. We gave language to it, but from the institution of the universe, all of these laws and properties that 1 equals 1 was instituted at the beginning of the universe. And so as we study mathematics, it's kind of cool to think that we're studying the design and the language of the creator in a way that's beyond our own creation. So let's get started. Today we're looking at linear functions. You have probably seen some of these forms or equations before. You've probably seen y equals mx plus b before. We already talked about m, where m is the slope, and b here is the y-intercept. And I think it's really important to note the form of the y-intercept is always 0, comma b. So that's slope-intercept form. There's table form, where you can put the x's and the y's, the inputs and the outputs, in a table. You can put it on a graph, where that graph looks like a line, a straight line with a constant slope. And then point slope form is another pretty important one. This will be edited in the notes, but point slope form does not have those 2's there. Point slope form actually just has y minus y1 equals m x minus x1, where m is that same slope, and this x1, y1 is any point. On the line. Cool. So let's get started. We're going to calculate slope in a very similar way to the way we calculated average rate of change in the last chapter, or chapter 2, I think. And so here's a first question. The first try, it says, find the slope of 2 points. And so I'm going to label these points as x1, comma y1, and x2, comma y2. And then I'm going to plug them into the slope equation, which says m equals y2 minus y1 over x2 minus x1. And I'll just plug in those numbers and see what we get. So we get 4 minus 3 over 0 minus 2, which is 1 over negative 2, which is just negative 1/2. So your m equals negative 1/2. And then it asks us a question, is this increasing or decreasing? And here we can say, okay, we learned about increasing and decreasing functions in the last chapter. Because it's negative, because m is less than 0, it is a decreasing slope. Which means that it would look more like this one. I don't know exactly how steep it'll be, but it'll look like it's going down. Like if it was your bank account, that would be a bad thing. Try it 2, pretty similar. Gives you, it doesn't give you explicit points though, so you might want to think about inputs and outputs. And I'm going to label these for you, but then let you try it on your own. So our input is, in 2009, that would be our first input, we have 1442 people. So that's x1, y1. And then in 2012, which is a second different input, we have 1,868 people, or y2. And so using those four labels, I would encourage you to maybe even pause the video and try this one on your own. Great. Now we're going to say, how do you actually find the equation of a line? So how do you find not just the slope, not just the m value, but the entire equation? And that's going to use this most important formula that we talked about earlier. Y minus y1 equals m x minus x1. So here we're going to label these points again. And we're just going to keep labeling our x's and our y's for a while until we get good at recognizing them without labeling them. But this is our first input, and this is our second, or our first output. And this is our second input, and this is our second output. And so the first thing I'm going to do is find the slope using that formula for m, which is y2 minus y1 over x2 minus x1. And so it's going to be negative 25 minus negative 11, pretty big number, over 4 minus 2. And negative 25 minus negative 11, it's going to be a plus because you've got two minuses happening. And so you're going to get negative 25, if you want to look at it that way, you totally can, plus 11. And that's going to be negative 14 over 2, which is just negative 7. There's your slope. It didn't ask us for slope. It asked us for something including more things than that, but there's our slope. All right. Now we're going to move to the equation they gave us, this point-slope form of a line, which is the last equation on that first page. And I'm going to say y minus y1 equals m, parentheses x minus x1. And you'll notice we have three of those things already in our problem. And so we're pretty much good to go. We're just going to plug those three things in. Y minus y1 was negative 11 equals negative 7 times x minus 2. And so that right there is the point slope form. The reason it's called point slope form is because we had a point and we had a slope and we plugged them into an equation to get the point slope form. But this problem didn't ask us to stop at point slope form. It actually asked us to go all the way to slope intercept form. And so we have to do one more thing, which is get y by itself. So that's going to be a lot like chapter 2, where we draw a line and we just move everything till y is by itself. So on this side, I'm going to reduce y minus negative 11 to y plus 11 equals, and then we're going to use the distributive property here to say negative 7x plus 14, which means y equals, move the 11 over, minus 11 minus 11. So y is equal to negative 7x plus 3. And that is what they actually asked us for, which is an equation in slope intercept form. So important to know those two forms as we move through today. Important for you to memorize and know the equations and how to use them for point slope form and slope intercept form. All right, this next question, I'm going to let you try it again on your own because it's just asking you to write a linear function, h of x, but I will help you label 2 points. It doesn't matter which 2 points you pick, so I'm going to pick the first one and the second one because those have the smallest numbers. If you picked a different point, that'd be fine. So let's label these as x1 and y1 and x2 and y2. And then from there, your step 1 would be slope. Your step 2 would be y minus y1 equals m x, parentheses, don't forget those parentheses, I almost did, x minus x1, and then 3, solve for y. Or you could say isolate y. So I've labeled your points for you and I've given you 3 steps. I would encourage you to try it. Pause the video, try it on your own. If you need a reference material, up above we just did the exact same thing with x1, y1, x2, y2, solving for y. So give it a shot and see what you get. And we'll keep going. We'll move on to graphing. So next we're going to look at how to graph a line. And we're going to learn 2 different ways to do it. They're about the same difficulty, so you pick your favorite. The first one is graphing a linear function with 2 points. So I'm just going to find any 2 points I can. The hint here is pick some easy numbers to plug and chug. So what's the easiest number to plug and chug in the world? I think 0. If we plug 0 into this function, it cancels the first term, or turns it, because anything times 0 is 0, and you're left with just 6. And so we plot 0, 6. That's 7. 0, 6. And then pick another point. You might be tempted to try 1, but if you plug and chug 1 into that function, then you're probably going to get a fraction, and I find that adding fractions is a little tough. So what if we picked 4? Because again, all we need is 2 points, any 2 points. If we pick 4, we get -3/4 times 4 plus 6. And you'll notice those 4's do a nice thing and get rid of the fraction for you. And so you just have 6 plus -3, which is just 3. And so if you plug and chug 4, you get 3. And remember, that table over there is technically just a series of points that we can graph. And so the blue point that we just graphed would be 4, 3, and we've got 2 points. Now we can grab a line tool. You can use the back of an ID or a pencil or whatever you can use to draw a straight line to connect those dots. And what you'll notice if you do it is that if you connect the dots really well through the centers, you'll notice that your slope stays pretty consistent. And so you may have heard slope called rise over run. If we take our m value, which was our slope, so in this problem we had an m equals -3/4. If we take that as a phrase called rise over run, so rise over run, then our rise, or how high up we went, was down 3, and our run was to the right 4, leaving the negative on the top and the positive on the bottom. And so if you watch what happens, we went down 3 over 4, down 3 over 4, and we got another point there. The next one's off the graph, but you could look at start at the beginning, and you could say if we went here, well, that looks like 2. The graph is a little off. There we go. We went. There we go. Much better. Go right here. No. Bear with me. Thank you. We went down 3 and over 4. So we have an extra point right there. Notice we only plotted the first 2 points, the blue and the red one, but we got a bunch of green points that came from just looking at the slope and the rise over run, which is actually the next strategy for solving these things. And that would be use the y-intercept and the slope to plot a line. And so here we have a different function with, if you remember from the beginning of the day, the y-intercept is 0, +5, which is your b value. Your y-intercept, also known as your b value, is 0, whatever that b is. And so I'm going to plot that point, 0, 5. That's about right there. And then what I'm going to do is I'm actually going to use rise over run and not do any points. And so the m is -2/3, which means I'm going to go down 2 and to the right 3. And so down 2 to the right 3, plot a point. Down 2 to the right 3, plot a point. Down 2 to the right 3, plot a point. And we're just going to keep doing that. And then we can follow that pattern backwards. And kind of how the way you can think of that is just change where the negative is. Because -2/3 is the same as, let's shrink this for a second, I'll show you what I'm talking about. -2/3 is the same slope as 2 over -3. And so that would say go up 2, but then go backwards 3. So then we're going to go up 2, backwards 3, up 2, backwards 3, and we can draw a line through all of those points. And that time we only needed to graph one of the points, that blue point, and the rest of it came from the slope using rise over run. And here try it 6 says, hey, can you just identify some point that has a negative x value? And so if we look like right here, that point is -3, comma, 1, 2, 3, 4, 5, 6, 7, 7. So if we plug and chug -3, we should get the number 7, which means f of -3 equals 7. You could check that if you want to with that original function by plug and chugging it. And yep, that's what it looks like. All right, so here is some like a chance for you to really tie it all together and try to determine some functions based on their graphs. And I think the easiest way to do this is the slope, using the slope and using the y-intercept. And so I'm going to start with the orange one. I'm going to say, what's the y-intercept of the orange one? For number 1, you have a y-intercept of b equals 3, which is 0, 3. And then we're going to find our orange slope by just counting. So I'm going to go, where's the next nice neat point? It looks like there's one right here. Looks like there's one right here. Looks like there's one right here. And so what does that slope look like? It looks like we went to the right 1 and up 2. To the right 1, up 2. To the right 1, up 2. It stayed consistent. That's what it looks like. So it looks like m was to the right 1. Oh, wait. M is rise over run. So the run was to the right by 1 and up by 2. So your slope is just 2. And then we put all that together in our formula, which is y equals mx plus b. And so y equals, our slope was 2x plus 3. And that'd be how to find, when you're given a line, using the same skills as y-intercept and slope, how to find the equation of that line. I'll leave you to try the other 3 if you want to. They're also written in the completed notes, so you can check your work. I would highly encourage you to do that and practice. One note that I would make that I was just thinking about was the slope is positive, which we talked about means it's increasing, like it's a good bank account. And you'd say if your bank account looked like that orange line, that's a pretty good thing. Actually, it looks like there's only going to be one negative slope. It looks like it's going to be this number 4, this dark blue function, negative slope. So be on the lookout for that as you try it by yourself. That slope looks like it goes down 2 and then over 1. So that -2 would get, that down 2 would give you a -2 on your slope. And so maybe I'll just give you that number 4 slope. M on number 4 equals -2 rise over 1 run. But I'll leave you to try the rest. All right, so far we've talked about the equations. We've talked about how to plug and chug some numbers to find the equations and to put them on graphs. Now we're just going to talk about a few key features of each graph. First key feature, x-intercept. What's an x-intercept? It's where that line crosses the x-axis. So if you have a line, doesn't even matter what it is, there's your x-intercept. Where does the line cross the x-axis? And how do we find it? We set the entire function equal to 0. We don't plug in 0. We set the whole thing equal to 0. So right here we would say 0 equals the whole thing. And then just like day 1, we would solve that equation by moving stuff over and getting x by itself. And so -4 minus 4 gives us -4 equals 1/4 x, which means x equals -16. And I'm going to be really careful here because an x-intercept is a point on a graph. And so I'm not just going to write 16 or, yeah, I'm not just going to write 16. I'm going to write, plus 4. How do you get rid of you might have been screaming at your computer screen saying, hey, you did something wrong. -4 plus 4 is 0 to cancel out. And so we should have had a plus 4 right there. Which means when we divide or multiply by 4 on both sides, 4 times 4 is an actual positive 16. If you were yelling at your computer screen saying, hey, I think it's supposed to be positive, good job, good catch. It's okay to miss something. That's why we check our work, and that's why we look back over it to make sure it's right. Because even someone who does it every day, all day long, it's really easy to just miss a negative sign like that. Awesome. So x equals 16, but x equals 16 is not an x-intercept. That's just an x value. To make it an x-intercept, we're actually going to write 16, 0, because that is a point on a graph. It's the point that you start at the origin, you go over 16, and you don't go up at all. And that's how to find x-intercepts. We've talked about horizontal and vertical lines before. You might remember we talked about this idea of hoi vux, where hoi stands for horizontal, 0 is the slope, and it's a y equals format. So in order to fill in this equation, we literally just go look at what the y value is. And so it looks like the y value is -4 right there at that point, and at all points. And so y equals -4 is your equation for that line. If you want a reminder of what hoi vux and all that talk, that was back in chapter 2, when we learned about the constant function, or the constant line. So I'd encourage you to go look at that if that was kind of fast for that. Here's a vertical line. The other side of that thing was vux, which stands for vertical, undefined slope. I'll write that out. And the format is x equals blank. And so you just go to your graph and you look at a point and you say, what is the x value at that point? And right here it looks like it's about 7. And so our equation for our line is x equals 7. And that's constant lines, horizontal and vertical lines. The last thing we're going to do today is parallel and perpendicular lines. We may have talked about this in a previous video. I don't remember, but we're going to cover it all here. So parallel lines do not intersect, and they have the same slope. It says it right there, slopes are the same, but if you want to remember it even shorter, parallel lines have the same slope. Perpendicular lines do intersect, and when they intersect, it makes a perfect right angle. And they have negative or opposite reciprocal slopes, which means flip-flip. It means you flip the sign and you flip the fraction. If it was positive, it's now negative, and if it was 1/2, it's now 2/1. And so here what we're going to do is we're going to be given a function, and we're going to find a line that's parallel to that function. So the first thing I'm going to do is look at this, and I'm going to say, what was my original m? M equals 2. And because I want parallel, I'm going to write m parallel and put these two little parallel lines there to let myself know that's my new slope. And parallel means same slope, and so my parallel slope is also 2. And then they give me a point to pass through. And so this I'm going to call my x1, y1. And I'm just going to use the point slope form. So we have y minus y1 equals m x minus x1. And I have those three things to plug and chug. I have my x1 and my y1, and I have my m parallel. And so I'm going to say y minus 0 equals 2x minus 0. And if you solve that down, you get y equals 2x. That is your parallel line passing through the point 0, 0. You do a pretty similar system for the next thing, where you say your original m was 2, and that means your m perpendicular, that's how I like to write m perpendicular, to remind myself this is the slope, and it's the slope that is perpendicular. I'm going to flip the sign, so now it's negative, and I'm going to flip the fraction even though it doesn't look like a fraction. Technically 2 is just 2/1, and so my new slope is 1/2. So my original slope for my original function was that m, 2. My perpendicular slope is -1/2. And then I use the same point that passes through to say y minus y1 equals m x minus x1. So y minus 0 equals -1/2, x minus 0 with parentheses, and so y equals -1/2 x. And there's parallel and perpendicular lines. So this try at 10, I'm going to do with you, even though it's pretty similar, because it wraps up the entire day into one big problem. So if you remember one thing from the entire day, it would be try at 10. So a line passes through points, these 2 points. Find the equation of a perpendicular, that's the harder of the two, line that passes through this new point. And so the first thing I need to do is find the slope. And so m equals, I'm going to label them, but then I'm going to skip writing the equation for you so you can kind of see us piece it together. M equals y2, which is negative 3, minus y1, which is negative 15, over x2, which is 2, minus x1, which is negative 2. And there's a lot of negative signs there, so I would encourage you to be careful and look at those negative signs carefully as you work with them. Remember, if you have two negatives next to each other, it's a plus. So 15 plus negative 3 is 12. And 2 plus 2 is 4. And so your original slope was 3. Remember, that was your original slope. I haven't given it one of those little symbols yet, so it's not our perpendicular slope. Our m perpendicular then is a flip. We flip the sign, we flip the fraction. Negative 1 over 3. And now I have a perpendicular slope and a line that, or a point that it passes through that lies on that line. And so I can use my formula of y minus y1 equals m times x minus x1. And so I'll just plug in those points. Y minus 4 equals negative 1/3 x minus 6. And then solving for y, we get distributive property first. Y minus 4 equals negative 1/3 x, that's the tricky part, plus, because a negative times a negative is a positive, 2. 6 over 3 is 2. Then to get y by itself, I'll move that 4 over by adding it. So we get negative 1/3 x plus 6. All right. And if there's no questions or no problems, that would be, actually I should have labeled that. That would be perpendicular line passing through 6, 4. Awesome. Well, that is the entire section of linear functions, which means that the very next thing you'll do is you'll have a test over linear functions. So if you need to watch this video again to practice, I would encourage you to do that. Try some of the try-its that we didn't do. Work through your homework problems, because those will be really important for you to master this material. And then good luck on your linear functions test that you'll take this week. Thank you for watching, and I'll see you next time.